Welcome, everybody. Thank you for coming. This is a NYNOG Meetup number 2. Big thank you to Digital Realty and Telex for hosting us here and allowing us the space. You're in for a fun, interactive workshop today on interconnection. What we're going to do is we're going to go through the basics of interconnection, talk about a little overview. We'll go into some of the engineering and operations aspects of interconnection and peering, and we will talk about the business of interconnection. We hope for this to be a little interactive, so we might stop and ask questions. If you're interested, feel free at any time, raise your hand, ask a question. All right, so for those that don't know a little bit about NYNOG, inspiration comes from NYNOG, which is a North American network operator group, focused on education, networking, community, and bringing people together that are really interested in network operations and building and operating networks. Our first meetup was in May. We're very focused on the New York market, so bringing everybody in this market together. As the community grows and becomes larger and larger, there's a lot of people local here that actually don't get to go to NYNOG. So why not start a local group? And you're at the second meetup today, so thank you for coming. Our focus is going to be on smaller meetups throughout the year, and next year we will probably do one big single-day event, kind of like Marketplace Live. And we're also in the process of formalizing the organization as an official nonprofit. We are looking for volunteers and sponsors, so if you are interested in helping out, or if your company is interested in sponsoring, shoot us an email, get in touch with me while here, and we're happy to talk about that. All right, so I'm going to start and give you guys a basic overview of interconnection and peering. And what that entails is just a very few basic things. We're going to talk about internet exchange points and peering. We're going to talk about connectivity to the clouds, the geography of where interconnection is happening, and we're going to touch a little bit on why community is so important for this, and we'll touch a little bit on some market and industry trends happening now. All right, so everybody knows what the internet is, right? AOL, Facebook. The internet is a network of networks. So picture the world with just a bunch of lines and dots that connect each other. When we talk about interconnection, specifically, that's the physical connection of one or more networks, and that's how the internet is formed. But there's also a logical component, and when we talk about that, that's also a piece of interconnection, and it's what peering is, and it's what meet-me rooms are, and the whole fabric that everybody connects to each other through. So peering, if you don't know what peering is voluntary interconnection of two different networks, specifically for the purpose of exchanging traffic. When we talk about peering, it falls into two categories, settlement-free and settlement-based. Your typical company might buy IP transit, and that's settlement-based interconnection. When you're joining an internet exchange or you're engaging in private peering, that's settlement-free. So some of the factors that really help build these two things. Settlement-free peering, there's no direct cost. There is a passive cost, and that's connecting to the internet exchange or buying a cross-connect. When we talk about settlement-based, there is a direct cost. You're paying a provider or carrier for your IP transit or for your paid peering. That's a commercial relationship. Usually with settlement-free peering, we're talking about no agreements, no contracts, although sometimes agreements can come into play depending on the relationship. Settlement-free is also bilateral or multilateral. Bilateral means that is a peering session between two parties. Multilateral means that's a session from one to many, and we'll touch on that a little bit later. Settlement-free via an internet exchange port, and settlement-based can also be paid peering, and what paid peering means really is customer routes. So if you have a provider like Comcast and you want connections and access to their customers, you can actually specifically pay just for those customer routes. Benefits of peering. This is a tricky one. So it can potentially lead to increased performance. It's not a given. You're not guaranteed you're going to increase your performance by just peering with someone. There's a lot of work that goes into it, planning and engineering work, and ensuring that you're delivering the appropriate content, delivering the appropriate traffic to those peers. Lower costs. This is also depending on regional and other factors. In some regions, IP transit is cheaper than peering. When you add up that cost of the cross-connect the peering port, and you look at IP transit, which is today about 25 cents a meg is the bottom line we're seeing, peering is no longer at the top of the game for being cheap. It does provide greater control by peering directly with networks, whereas traffic and routes you would most likely see through a transit provider. You now have more connectivity to them, and you're able to control what you see. With that said, it can also increase capacity to those networks because you're now alleviating that IP transit connection and moving that traffic over to direct peering connections. Internet exchange points. Anybody that's not familiar with internet exchange points? Nobody? Everybody knows what an internet exchange point is? All right, internet exchange points are a platform that facilitate the interconnection or peering of two networks. They're basically a layer 2 switch. They act transparently, as I said, facilitating the interconnection using BGP. Operating models include commercial and nonprofit. Telex, Digital Realty, operates an internet exchange, and that is a commercial internet exchange. Equinix operates the Equinix Internet Exchange, commercial. Then you've got people like AMSIX, the Amsterdam Internet Exchange, who has a presence in New York. They're a nonprofit internet exchange governed by their members. They've been around since the 90s when we're talking about May East and May West. And there's some standards and certification component when it comes to internet exchanges called OpenIX, which was a group created to foster standards and create a standard playing field for internet exchanges and data center meet-me rooms. So route servers, I talked about earlier, multilateral peering. What multilateral peering falls into place is with route servers. Route servers are a software router running BGP operated by the internet exchange. They're a one-to-many platform. You turn up BGP and connect to that route server, and you receive all the traffic and routes from all the other participants that are connected. So it really cuts down on the overhead. You no longer have to reach out to every single network or organization that you want to peer with. You just turn it on and you're good. It has BGP communities for control, which are basically tags that allow you to say what you want to do with that traffic. So if you want to accept routes from certain providers or you want to deny routes from certain providers when you're peering with that route server, you set those BGP communities and you can make that happen. And Ryan will touch on that a little bit more when he talks more about engineering for interconnection. Connectivity to the cloud. So 82% of enterprises have a hybrid cloud strategy today. That's a lot, and it's growing. What that means is enterprises are using multiple clouds, or they're using cloud and they're using their own data center. So there needs to be a gap to really bridge those connections. 57% of enterprises are focused on moving more workloads to the cloud. So these two metrics right now really pave the way for connectivity to the clouds. You need a way to connect your IT infrastructure in either your own data center or even your corporate headquarters to that cloud. If you're running IT workloads, adding that connection from your office will help increase performance and add security to that. So connectivity to the clouds, there was a big announcement today, if you all heard, the Digital Realty Service Exchange. So they're going to be a big player here. We've got the basic major cloud providers here, and this is the product. So you got Amazon Web Services. They have Direct Connect. Microsoft Azure, ExpressRoute. Google Cloud Platform has Cloud Interconnect. Oracle Cloud has Fast Connect. A lot of people might not know about that. Equinix is actually the only one providing that connectivity right now, with probably more to come as they develop it. Other providers that you can get cloud connectivity from, traditional carriers like Zayo and Level 3, next generation platforms like Megaport, incumbent cloud exchanges like Equinix has got a cloud exchange in their own four walls. You can get that connectivity to all those cloud providers. Interconnection geography. So this is kind of a glimpse at the major hubs where interconnection happens. Asia Pacific, we're looking at Tokyo, Hong Kong, and Singapore. Europe, we're looking at London, Amsterdam, Frankfurt, Paris, otherwise known as FLAP. In North America, we've got New York, Ashburn, San Jose, Los Angeles, Chicago, and Dallas. And what makes those interconnection hubs is fairly simple. Proximity to submarine cable systems, landing stations. It's a gateway to international regions. So when you talk about New York, we're a gateway to both Canada and Europe. Chicago is a gateway to Canada. Dallas is a gateway to Mexico. Los Angeles, gateway to Mexico. San Jose, Los Angeles, Palo Alto, gateways to Asia. And there's other aspects that really attribute to these being interconnection hubs as well, and that's economic factors, the availability and density of terrestrial fiber. And also sometimes coming into play are regulatory and policy attributes. When you really leave the US and some places in Europe, you're going to run into much more regulatory issues when it comes to interconnection. And it's imperative to really understand those to be able to navigate that market. Communities plays a very large role when it comes to interconnection and peering. This is where you meet your peers. This is where you meet your potential peers. So there are events just like this, and these are your network engineers, your network strategists, your peering coordinators, anybody you should talk to if you want to set up that connection between your network and theirs. Some of the operator groups, you've got NYNOG, you've got NYNOG, of course, and you've got CHINOG in Chicago for anybody who's local, might be local in Chicago. You've got BOSNOG in Boston, who's also doing the same thing, and I think you're going to see a lot more of these operator groups really start to pop up in local regions in the US. Then you've got the peering forums, the European Peering Forum, the Asia Peering Forum, and the Global Peering Forum. So Global Peering Forum will be in New York next year for the first time ever. So if anybody is working on peering or anything like that, follow that. I think the address is peeringforum.com. I'm not really sure, but check it out if that's your thing. Market and industry trends. A few things kind of been happening, and they continue to happen. That's 100G is the new 10G, and this has been on its way for quite a while right now. But most of the major and larger networks, 100G is the only way to go. So if you're on the business side, the carrier side, internet exchange side, and you're not offering 100G, you're behind. Not everybody will continue to use it, but you'll start to see smaller speeds and lower speeds fall off. IP transit pricing, as I mentioned earlier, about 20-25 cents a meg these days, continues to fall. Not seeing a real bottom yet, and it will probably continue to fall a little bit further. IP transit pricing is less than internet exchange pricing, as I mentioned earlier in some regions. So, just thinking about peering is not always the best move. You've really got to put a plan together and understand what you're getting into before you do that. There's a big myth that peering is free. Peering is not free, as I mentioned it. There's costs that are related to peering. So peering is not free. It's not always the best alternative to IP transit. We've got the re-rise of the aggregators, which I like to say the old tier 3 networks, people that are aggregating IP transit providers, providing other connectivity through their platform. And you're seeing this through companies like Console, through Megaport. They're all providing connectivity. So essentially they're aggregating that connectivity on their own platform. Second and third tier markets are really gaining popularity. If you look at people like EdgeConnects, deploying data centers, small edge data centers, as I like to call it, in smaller markets, that's becoming much more popular. Content wants to be as close to the user as possible, and these markets are what provides that. All right, any questions on basics of interconnection and peering before I hand over to Mr. Helmenstine from Telix? It's if he's connected to an IXP and he wants to peer with 3 different people, does he need 3 separate ports? No, and that's the beauty. That's the logical aspect, right? The physical aspect of the interconnection is that you connect to the IXP. And then your logical interconnection is the peering, which is utilizing BGP and happens over that physical port. So you get that one connection, and now you can peer with those 3 networks utilizing BGP over a single port. The IX does, yeah. That's the exact purpose of the IX, so facilitates that logical connection. All right, well, let's welcome Mr. Peter Helmenstine, who's going to talk about the business of interconnection.
Thank you. I'm filling in for Adam Rothschild. You couldn't be here today, so I work for Digital Realty, focusing on network architecture. So I'm going to focus on what it's like to kind of like be a buyer and dealing with how you deal with all the costs with that. So, and I kind of broke it down into pretty much these areas. I'm going to start with hardware. when you're dealing with hardware in the network industry, there's not much that depreciates faster than like routers and switches. I recall one of my first jobs as a young tech, putting a $300,000+ router in my truck and driving it to the Wested building in Seattle, and then just a couple years later, that thing was worth less than my truck. It's amazing to see stuff just drops like a rock, including like optics, 100 gig optics. We were quoting those for about $45,000 a couple years ago. Now I think I just got a quote that's around $2,000 to $3,000 these days. So dealing with the stuff, you really got to take a long-term picture about how you're going to buy the stuff and how long it's going to last in your network to be able to get that ROI on it. And if you're big enough and you buy the stuff in bulk, if you go directly to some of the larger vendors like Cisco, sometimes you can actually work with them to do a financing or a leasing deal where you lease it out for a period of time and then you have the option to buy afterwards. So some folks actually, depending on what you're doing and how complex your network, you can just get away with using just regular routing, switching, and if the code is solid enough, you can get away with just gray market, hot spare it, and your network will be fine. But if you're really working on something that has like, bits of code in there that you have to really rely on, you're going to want to have a maintenance contract to kind of support you on that. And those maintenance contracts can get very, very expensive. So when you're buying IP transit, if you want to be able to connect to the public internet, you got to have a public IP address. So there's different ways to do this type of cost analysis. You got to deal with getting your own IPs, which Aaron is now out of IPs for North America, so you have to buy that on the gray market. Or hopefully you know somebody who's got some and can work with you on that. Some of the internet transit providers, they'll actually sell that to you or lease them out. When you're dealing with the actual billing methods, there's a few different ways to deal with that as well. So there's usage-based pricing, where you basically pay for what you use, and they call the method of doing that 95th percentile. So that's like 95% of the actual usage that you use over a course of a month, and they do 5% that they take out in case you have these anomalous bursts that get in your traffic that you can kind of remove that, and it's basically just usage-based. Other ways of doing it are fixed rate, where you actually buy a certain commitment level on a circuit. So say you're buying a 1 gig circuit and your commitment to actually using that is 10%. So you got usage, you got fixed rate, then you have burstable. So say you can buy a 1 gig circuit, you commit to 500 megs of that, but if you go over that 500 megs, then there's some overage charges on that, and you get billed per megabit on that. Aggregate, so if you have multi-site locations, you're basically committing to an aggregate usage, even though you might have like 5 to 10 different ports. Sometimes the ports are NRC, so there's different ways of dealing with that as well. And then SLAs are something you also have to really take into account. So when you're dealing with internet transit, depending on your business model, if you're okay with just connecting to the public internet and you know that it's going to be kind of like the Wild West, you're not going to get total 100% guaranteed to get your traffic from, say, one location to Africa. You're going to cross the public internet, and you're not going to get 100% guarantee to be able to get across that. So ways of dealing with that, you can go to a certain set of providers like an NTT or a Global Crossing, which is now level 3, and usually a couple different providers are good, and you'll be fine with that. Other people are very, very sensitive. They need to be able to get their traffic out the door as quickly as possible, like a Netflix, where they actually need to be able to connect to an internet exchange. Excuse me, I'm not going to be able to continue. I got a frog in my throat. You mind?
Oh, yeah. I could check it out. Let's see. Improvising. All right, we already touched on internet exchange models kind of a little bit. Port costs can be variable when it comes to this. Some internet exchanges, you'll get a flat fee for a port for the year. Some you'll pay monthly. Some you even have free. Florida Internet Exchange, underwritten and formed by Netflix, Zayo, and a couple other guys, offering free internet exchange ports. Can't really beat that. PairingDB, great tool to really find your peers and understand who you need to connect with. Check it out. It's got every site, every network that's peering, where they're peering, contact information. So if your network is peering today and you need to find and reach people, go ahead and check that out. Private line, so we're talking about Metro Ethernet, waves, dark fiber. Dark fiber, really cheap these days in a lot of markets. Metro Ethernet, kind of think it's on its way out myself with all these other providers and new technologies coming into play. Location, everything is different. We kind of talked about the hubs of interconnection, where it's happening in the world, what the geography looks like. When you get deeper in that, there's a lot more aspects that really come into play here. As knowing who has the right of way. If anybody's familiar with 111 8th Ave, 60 Hudson, yeah? Very tricky buildings to navigate. You might be in one suite and someone you want to peer with privately is in a suite across the hall, and that cross connect might cost you $700 a month. Or there might be an internet exchange that's co-located a floor beneath you, and might cost you $800 to get to that floor a month. So when building and deploying networks and internet exchanges, it's very important to consider how the building is operated, where the risers are. If you look at DKIX New York, they built an exchange here, and they did exactly that. If you go look at their site and where their locations are, over 100 access points in New York. They really thought about that when they deployed it. So no matter what suite you're in and no matter what building, you're gonna have easy access to them. So 90% of the time, nobody actually owns the whole path. Sometimes you're gonna go through two providers, and that can cause major headaches, especially on the operational side, not to mention on the cost side. Then there are different things like home runs versus cross-connect packs, depending on the colo provider you're dealing with. So you can either get a home run between your network and the other network, or you get a pack of cross-connects that traverse the meet-me room. So a little bit of summary. Everything really trickles down to location when you're talking about cost. Some markets are cheaper than others. Others are more expensive. And you've got some tools that you can check out that will really be helpful when you're planning and strategizing around how to interconnect your networks and really how to deploy your network robustly, create for resilience and all that. So PeeringDB, CADA, get your building carrier lists. Most people will just give it to you. Or if you're people like Zayo who kind of want a different approach, you can get it all online. Go get their KMZ files and look at their whole network and where their fiber runs through, just right from their website. Industry contacts, like it touched on community earlier. Use that community, and if you need to get in touch with someone, it's most likely someone will be able to know it, especially if you're here and you want to talk to a network. You come here, you talk to somebody, you ask somebody for an introduction. Somebody will know who you need to talk to. All right, and any questions on business side of things, cost?
So you said, sorry, thank you. So basically you set up your ISP, get that from GoDaddy or whatever, Google, and you set that up, like any ISP set up, you get any domain map, it's really a directory, and you're on the internet. It's really the responsibility of the ISP once they've given you the bandwidth to get the interconnect. Like, I shouldn't really have to worry about getting that done. Am I right? Or, I mean, I can understand like model like Netflix, they care about like how quickly you want the user experience. But for a normal site, which is mostly data driven, although it may have graphics, is a one-time download. Can you expand on that a little bit?
Right, exactly. So if you're just operating in a hosted space or you're using a cloud, like you're using Amazon or you're using DigitalOcean or one of these guys and your site is hosted there, then they're going to be the ones that are actually worrying about the interconnection and the peering. One of their goals needs to be to make that connectivity cost effective for them and performing optimally for their customers. So that kind of lies in that cloud provider's hands, in that hosting provider's hands, in the service provider's hands, the carrier, depending on what you're buying.
So a follow-up to that is, maybe it's an appropriate question for Netflix because we've heard stories as to once you go into AWS internally, it's virtualized and you don't really know where is what unless you get metal level. So there are really 2 points as somebody who wants to use these services, right? There's one that would be internal to the network, and then there would be the other one, which is the network group that you talked about. That's on the other side. Am I right? So as somebody who builds application and hosts it in a service, I really need to think from two aspects. One is internally in the cloud, that's the actual infrastructure, hardware, whoever the provider is, and then the other one is the network. I mean, come out of that. And I think I would love to see what you've seen in the market in terms of, we have to promise as a provider of the application SLAs to the client, and I think they would directly be dictated by something like that.
Yeah, no, absolutely great point, and I think we need to see more teams internally, the application teams, software teams, working with the infrastructure and network teams, so they really understand each other's needs and can set expectations on that kind of thing. So if you're running, whether it's a B2B or a B2C app, you need to be able to understand how that connectivity impacts customer transactions, no matter if you're hosted or if you're running your own infrastructure. I think one big thing, though, today is applications are becoming much smarter. Maybe Ryan will be able to touch on that in his presentation, or even now. Let's let Ryan touch on that.
I can speak to the Netflix question in particular, and also generally to the idea of how the control plane versus data plane splits. If you had, for example, just purely a desire for internet transit, you could take that business to a facility like 111 8th or 60 Hudson, where you had a choice of carriers, and you could procure dark fiber, you could procure waves, et cetera, and put hardware there and have your choice of presumably cheaper transit. And sort of as a side effect of being there, you could interconnect with all these other networks that are there, including Amazon potentially, both on the VPC side and on the public internet exchange side. They're present in many exchanges, and also, for example, with Netflix. And whether that's a value to you depends on what your traffic looks like. If you are an access network and Netflix makes up 50% of your inbound traffic, there's a pretty good value to you in showing up at a site like 60 Hudson, maybe 111 8th, and interconnecting with these networks with whom you exchange a great deal of traffic. So that's sort of the value that you could gain from peering in that case. Does that sort of answer your question?
Yeah, it's just great to hear how you have reduced the cost of transmission down to a few cents per movie. What you guys have done internally.
Sure, definitely building the big CDN is helpful.
So I guess I'd love to, in your presentation, if you can touch base on how you did that from an infrastructure point of view, in a sense that it's hosted at a third party.
Sure, yeah. So there's a, real quick, won't go too far down this road, but there's a control plane, data plane separation, and AWS is just the pre-play interaction. And then the data assets, which are the bulk of the actual capacity that's sent, are sent from 60-ish locations around the world, which are ones where we openly peer on internet exchanges in addition to private interconnectivity and some other solutions.
Thank you.
And just real quick, if you're really interested in more from an application view of things, future NYNOG meetups, we're going to really dive in and get some software engineers and more network engineers to really talk about how that all works and how teams work together and how you build apps in today's world for optimal connectivity. So go to our website and sign up for the list so you're informed about those if you're really interested.
I'm there.
Cool. All right. Thank you to Ryan.
Thanks. All right, so Ryan Woolley, I work for Netflix as the Director of Global Network Architecture, also a volunteer at Community IX, which is the operator of the Florida Internet Exchange. So I can hopefully offer you some perspective as a consumer of Internet Exchange and also an operator and a generator of a fair amount of traffic. So hopefully, based on the sort of introduction you had, the business context, that you can make a decision as to whether or not peering makes sense for you, and give you an idea of how to get started with that, how to figure out where your traffic is going, what sites you'd want to interconnect at, and what you can expect from a day-to-day operations perspective. So from a turnup standpoint and from an ongoing maintenance, and sort of what you could presumably expect to go wrong. And together you can figure out if this is something that you want to sort of offload to IP transit by just purchasing transit, if that's the best case for your application, or if peering makes sense for your user needs and from a cost perspective. So diving right into the technical details, you'll need a couple things to get started. Presumably, if you're buying transit from someone today, you're either multi-homed or not multi-homed. If you're not multi-homed, you probably just have a default route and some IP space that the provider has given to you. If you are multi-homed, you probably already have some IP space. Maybe you have some provider independent space from Aaron, perhaps you have some space that you've obtained from one of your providers that they've given you the right to use. The important thing is that you have some IP space that you're able to announce in multiple places. And of course an ASN. So again, if you're multi-homed, you already have this, but it's a necessity to participate in this ecosystem. A router with an appropriately sized fib is something that's very near to me, since we have a lot of devices that are not full-size fib. But conventionally, the difference between a router and a switch is both the feature set and the capability to store a certain number of routes in hardware. And this is called the fib. As it turns out, that for some limited applications, you may actually be able to store enough routes to get what you need. Not a full internet transit table, but just the routes that you're interested in smaller switches. To give you an example, Trident 2, which is the chipset that's in like some of the 1U Arista switches, actually can hold 144,000 routes in the hardware forwarding table. So this won't hold, like say, a global route table, but it is enough if you want to join a route server at Telex, for example, where I looked this morning and there were about 7,500 prefixes. So you sort of have to look at this as a sort of bits per route and decide if it makes sense for you to invest in the hardware that's capable of taking all these routes. Netflix is sort of the extreme example. We just send local routes, and there's a tremendous amount of traffic on that. So how do you figure out where you want to peer and with whom, and therefore if it's valuable to you? The best way you can do this today is to look at your NetFlow data. You're probably collecting NetFlow. Maybe you're collecting NetFlow, but you may not be doing it with a full BGP table. So the value here is looking at the traffic that's flowing through the switch and sort of marrying that data to BGP to determine what the actual AS path is and where that traffic is going across the internet. You need the full BGP table, but you don't necessarily need to program it in hardware. So if you have a switch a router that can support the entire table in software, but not in hardware, you can use a feature like selective route download to provide that information to your NetFlow collection systems. There's pictures there of examples of 3 different very common NetFlow systems. On the far left, you'll see a commercial product called Kintec. Arbor is another competitor in that space. In the center, a product called NFSend, which is a very popular open source application. Obviously very command line oriented, sort of a basic web UI, but simple to get started with. And on the far right, a lot of folks have built systems for NetFlow analysis using Elasticsearch, Logstash, and Kibana, which is collectively called ELK. And there's some opportunity to sort of build that yourself if you're interested in looking through the presentations that have covered that in the past. We touched on this a little bit earlier, but PeeringDB is probably your best resource to figure out where networks are going to connect. So if you decide that most of your traffic is coming from Akamai, Netflix, Microsoft, et cetera, you can look in PeeringDB and determine where those networks are going to peer and decide if it's a place where you already have connectivity or you're interested in procuring connectivity. Individual IXs, I have NYNOG's member list up here in the center. They're the exchange operator in Portland, Oregon. Individual IXs will publish a list of their vendors, or their members rather, so you can see who is available on their IXs. And the same is true of commercial operators like Digital Realty. So if you look at a specific site, you can see who you might be able to reach on those networks. And sort of the individual choice of the participant on the IX, whether or not they're interested in connecting to you. But you can approach those folks and if you decide it makes sense and consider peering with them. And as I mentioned earlier, you can use this data set to figure out where you'd want to connect. You may, as I mentioned, already have equipment that you're using to procure transit from multiple providers at a particular data center site. So you might want to look and see who you could connect to at that data center site. And you have to sort of figure in the cost of the transport to that site versus the cost of just purchasing transport from rather from someone like Level 3, who will drop it off at any location and save you the operational overhead of this. So you just have to balance those two factors. If you made a decision to turn up a port on an IX, there'll be a couple things you'll be expected to do, and you can expect from the IX operator in order to make that happen. The circuit testing is something you're certainly familiar with, but something that's sort of unique to the IXP turnup process is being placed in a quarantine VLAN. So IXPs are typically just layer 2 switches, as was mentioned before, and you'll be placed into a quarantine VLAN where the operator essentially uses TCP dump to look at the traffic that you're sending. It's very, very common for networks who are new at this to send IPv6 router advertisements, CDP, STP, various link layer protocols that you really don't want on a layer 2 fabric. They're very much harmful. So the operator will identify those for you and tell you to turn them off, basically. Once you have that taken care of, you can sort of ping the test host on the quarantine VLAN, and they'll take a view of your MAC address. Most IXPs lock things down to a certain number of MAC addresses or to a specific MAC address, which is a problem we'll cover a bit later. But that stage will be used to identify the MAC address that is used on your hardware. And then eventually you'll be moved into the production VLAN. Once you're there, the easiest way to get traffic is to join the route server. With relatively low overhead, with just 1 or 2 sessions, you'll get every other participant's traffic on that route server. You can also look individually for networks that are appropriate for what you do. If you are an access network, if you provide condo internet, you have an educational network, and you have residential housing, that sort of thing, most of your traffic will be inbound from larger content networks. And vice versa, if you are a content provider, you'll want to look for local folks who are providing access. I say local specifically because you'll probably have a better time approaching the local ones, at least initially. Continue to watch this traffic with the flow tools that you use to determine if this was a smart thing to do in the first place, and continue to reevaluate that. IXPs can help you with this as well. There'll be port graphs. There's a very common product called IXP Manager, which is put out by a group called INEX, which is the Internet Exchange Point in Dublin. And INEX has a very common portal. It's used by a number of different ISPs, and it will provide you with peer-to-peer graphs, so you can actually see where this traffic is going and determine if it's someone that you want to establish a bilateral peering session with, or someone that you might want to split that traffic off onto an individual cross-connect, which you could do presumably for less money than you would pay for the IXP port. There's a couple things you need to do as a responsible participant on an IXP. When you buy transit, you have someone who's doing filtering for you on the inbound side, at least some level of filtering, and also filtering your outbound advertisements if you're multi-homed. They're sort of preventing you from doing stupid things and other people's stupid actions from affecting you. So you have to take some of these things and do them yourself if you're a participant on the IXP ecosystem. I'd encourage you to aggressively filter by prefix. Don't leak someone else's prefixes. Don't originate the infrastructure routes in your network, that sort of thing. And also to filter on AS paths. Basically lock it down as tightly as you can so that the other participants don't get unexpected routes from you. Don't advertise the IXP segment to peers. Most of the IXPs are very sensitive about this and have automated systems that will detect this. But just because it's a connected route on your IXP-facing router doesn't mean that it's something you should advertise to other peers. Exact prefixes in the route registry. So you'll be expected to place your routes into a route registry that other people can use for filtering and get an idea of who you're providing transit to, for example, and what IP space that you'll be announcing. In many cases, IXPs require exact prefixes. So if you intend to announce simply a /24, don't register a /22, register as exactly a /24. It's a feature that's, again, in IXP Manager, which is commonly deployed. You can expect anyone you connect with to accept prefixes that are 24 and shorter and 48 on v6. So don't expect them to honor your 25s, 26s, et cetera. It'll just get dropped on the floor. There's another number of common problems that you'll see as a participant. You'll see occasionally people sending you routes and essentially leaking routes that you don't want. Max prefix is sort of the base feature that you would want to use to protect yourself against that. So as you establish a peering session or as you look at someone's peering DB entry, you'll get an idea of how many routes you can expect from them. Maybe it's 100, maybe it's 500, something like that. And you can set a max prefix that will trip the BGP session and shut it down if you exceed that. This is especially important if you have a limited FIB device. You don't want the whole FIB to be consumed and stop forwarding because of a single entry. So it's especially important that you do that. And also if your router supports it, that you take advantage of features that will warn you when you're approaching that maximum. Usually it happens via syslog, and then respond to those. Either determine whether that's a valid setup and whether you need to increase the number of routes, or whether max prefix was doing the right thing and shutting that session down. Again, as I mentioned, when you're participating as an IXP, as part of the IXP ecosystem, there's no one who's protecting you against routes that you don't want and traffic that you don't want. So you'll need to apply realistic filtering. In some cases, may have been applied for you on transit. You'll also want to filter probably on tier 1 ISPs in the routes that you receive. It's not reasonable to expect that a small network is going to send you the routes from Cogent level 3, GTT, et cetera. It's simply not going to happen. So that's a leak, and you should make sure that your filtering drops that, or at least consider that you drop that in your filtering as a protection mechanism. A couple things that you may run into if you're new at IXP peering that are worth mentioning, so you sort of don't trip on them. There's a feature in BGP called Enforce First AS, which ensures that the first item in the AS path that's received from a given peer matches that given peer's ASN. Route servers sort of break that. That's a function of the way they operate. So you'll need to disable first AS on the route server sessions to do that. As an IXP operator, it's relatively regular that we get a call from someone and say, hey, I changed my MAC address. I really, really need you to change your access list right now. It's really important. So if you have a planned hardware upgrade that's going to affect that MAC address, or you've perhaps launched an RMA with a vendor and the MAC address is tied to the hardware you're RMAing, consider giving them some advance notice so that they can maybe add a second entry to that access control list, or schedule with you changing that, and that'll prevent downtime. You should familiarize yourself with the route server communities that are available to you. There's a couple different things you can do, like triggering real-time black holes for denial of service response, and selective drop of announcements. So if you don't want your advertisements to be propagated to a specific ASN, you can tag your routes with a community that will indicate the route server should not pass those along. So you get an idea of what those communities are before you decide that you need them, and it'll save you a bit of headache. That was the items I had to cover. Questions on that for me or anyone else here?
So I think now also we'll do a few minutes of questions. If anybody has any questions for the group or for they want to talk about throughout the whole audience, now we'll do that. After that, we'll all be available for individual questions. So if there's something you want to ask, maybe you want to ask for some help on understanding internet exchanges in New York, or maybe you want to ask something about cost related, or maybe you want to learn about how to get a job in peering. We'll all be available as soon as that's done. You can come up and ask those questions, and then we'll just get into some networking, or you can just run off and get some coffee.
I have a question. I'm wondering, I think that you might have sprinkled in answers for this with all three presentations, but you just advised for us to watch the IXP traffic flow through their own portals. But with this interconnection, I'm wondering, does this network peering model have the ability to automatically orchestrate traffic between multiple networks? If you apply a model to it, if to automatically orchestrate your applications or any of your traffic built on thresholds and things like that, does that make this easier for us to do, or do we still? And then also, I've got a two-part. Sure. Does it also limit the network monitoring that we have, and might have in place already for carrier edge information? Because now we're going through the peering model.
So answering those in reverse order, I think that it's complementary to whatever monitoring you have, and probably shouldn't have any adverse impact on that. To your first question, I don't think there's a mechanism for automated setup of peering sessions, at least bilateral peering sessions. Sort of the route server is the closest thing that exists to that, in that those people who are willing to participate in the route server and desire for sessions to be for the routes to be passed to each other automatically will participate in the route server. It requires action from both sides to engage in bilateral peering. So you could certainly have an automated process that would notify you if you had the amount of traffic that was in excess of a threshold, and maybe kick off a human response to engage that participant in a request for peering. But there isn't automated functionality that sort of sets up, that I'm aware of, that sets up sessions beyond some predictable threshold.
The automation of the peering is starting to come about. There's formats for how the peers are, in the peering DB, there's JSON formats of what the peers are, what their configurations are, and it's getting better, but it's still very much a manual process. As far as manipulating the traffic, there are some software tools that are out there. A lot of it, with the big guys, they generally have their homegrown tools that kind of monitor and shift traffic appropriately.
Anybody else? Anybody in here connected to an internet exchange or peering today? Anybody have plans to? Anybody know how many internet exchanges are in New York City? Too many. Anybody know a specific number?
6.
Even more. I think it's 8 with one that's actually really defunct. So yeah, like Alex said, it's too many. There's actually no need for that many internet exchanges in any market. 2, maybe 3 max the most. You get redundancy. So New York's definitely got an internet exchange problem. Any other questions? All right, well, we'll all be available now and break out, and everybody can just network a little bit. Thank you.
Thanks.